Good morning, friends. Today, the laws of conservation of the energy, the law of conservation of the energy, and this is a chapter work, energy, and power. So, the law of conservation of the energy. So, previous topic conservative forces, non-conservative forces, work kind of definition of the work. So, what is the law of conservation of energies? So, the law of conservation of energy, the energy can neither created energy can neither created nor nor destroyed nor destroyed. So the energy neither created nor destroyed, but 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 it can be it can be changed one form to other form, one form to other form. Okay, so this is called, so here in this one the total energy is equal to constant, total mechanical energy is equal to constant, total mechanical energy remains constant. This is called conservation of the energy. So what is the conservation of the energy here? So always energy is not created, not destroyed. Energy is not neither created nor destroyed, but it can be changes one form to other form. So the total mechanical energy will be constant. For example, here suppose this is a tube light. Okay, so this is a tube light. Okay, so when the switch is on, the switch is on, this is a electric power switch. When the switch is on, what happened? The tube light is giving a light, tube light is giving a light. So where this is a light means, here switch means electric. When the switch is on, their electric energy, current, the electric energy is converted to, it is give the light energy. So always the energy is transferred one form to other form, one form to other form. This electric energy to light energy, or light energies to another photoelectric effect, the electric energy. So that is always the energy is neither created nor destroyed, but it can change one form to other form, one form to other form. So this is the one of the definition. And the second definition, okay, so the total mechanical energy, total mechanical energy, m dot e, the total mechanical energy of the system is constant, system is constant. So what is the condition here? The internal forces, the internal forces is conservative, and external forces do no work. This is also another definition. Here the total mechanical energy is constant, total mechanical energy of the system is constant if the internal forces are conservative, the external forces do not work. Here suppose the external forces will be changes, that is a non-conservative forces. So what happened, their mechanical energy is changes one form to another form. So this is about of a, so law of conservation of energy. In this law of conservation of energy, so the two energy will be equal. For example, their mechanical energy is equal to the sum of the sometimes kinetic energy plus potential energy. Okay, the total energy, okay, their mechanical energy means the total energy is equal to kinetic energy plus potential energy. So here I am taking the one application. So what is the application? The application, for example, here I am taking the freely falling body, freely falling body. In this freely falling body, for example, this is I am taking the freely falling body. In the freely falling body, the total energy, the total energy is conserved. I will prove this statement. Okay, so what is the example? In a freely falling body, the total energy is conserved. What is the total energy? The sum of kinetic energy plus potential energy of any points will be constant. If you kinetic energy plus potential energy of, that is total energy is constant is any point, so that is the proof of the law of conservation of energy. I will prove now. Here I am taking the one example, freely falling body. So this is the one object. So this is the one object, right? Their object to mass m. What is the mass of the object? Their mass of the object to m. So it is a particular height. So this is a ground. Here what is the height of this object? I am taking capital H is equal to height of the object. Okay, so let us take one object or ball, any object. So what is the mass of the object? Small m at particular height with respect to ground. At particular height, what is the height? Capital H with respect to ground. So when this object is a freely falling, it is comes downward, it is a freely falling, what happened? You observe what is the total energy of any point. Here this is a 1 point, this is a 1 point, this is a 1 point, this is a 1 point. So you can observe what is the total energy is a freely falling. So what is the total energy? For this purpose you can calculate kinetic energy and potential energy of any point. So here what is the total energy? Means the total energy is equal to sum of kinetic energy plus potential energy. Here what is the total energy? Here also sum of the kinetic energy plus potential energy. So what is the total energy? Here kinetic energy plus. So what is our assumption? At any point the total energy will be constant. This is if you constant in a freely falling body, so it's give, that is a conservation of the energy. So I will derive the equation. Suppose here this is a one object. Okay, so this is a ground, right? So this is a ground. Here the object is a freely falling at initial position capital A. So what is the height? The total height capital H. Okay, so the total height capital H at point A position, so this is a mass m. So what is the potential energy? So here I am taking first situation at point to capital A. Okay, I am taking the 3 points, point A, B, C. So at point to capital A, so here at this point their particle mass m, so it is having some height capital H. What is the potential energy formula? Potential energy of the A at the point A, formula mass mgh. So what is the height? Height is equal to capital A. So this is the potential energy at point A. And what is the kinetic energy at point A position? So what is the kinetic energy formula? We know that very well, of mv square. Of mv square. So v is equal to velocity. So at this point here, what is the initial velocity? The initial velocity here, v is equal to u is equal to 0. Because it is a freely falling at the maximum height, their particle velocity will be 0. So v is equal to u is equal to 0. Substitute in this kinetic energy equation. So kinetic energy at point A is equal to 1 by 2 m into 0 square into 0, 1 by 2 m into 0. So automatically what is the kinetic energy at point A? The kinetic energy is equal to 0. What is the total energy? The mechanical energy, sum of the kinetic energy plus potential energy. So that is, what is the kinetic energy? 0. Potential energy is equal to mgh. So what is the total energy? The total energy is equal to mgh. Total energy at point A. Here in the diagram, at point A, what is the total energy? At point A, the total energy is equal to mgh. Next, at point B, here this is a particle mass m. Okay, so this is a height on a ground. At what is the point? Initial point A, right? Initial point A is a freely falling. At what is the height? Capital H is equal to height. Suppose at the point A, their object is a freely falling in the downward, it is a reaches at this point. This is a reaching point. Suppose B is the reaching point. So when the point is coming from height A to B, how much distance will be moved? Just this is assumptions. Here S is equal to X. How much distance will be traveled at point A to B? So S is equal to H. So here, so you can find at this point B what is the kinetic energy and what is the potential energy. Calculate kinetic energy and potential energy. Kinetic energy and potential energy. So at point B, I am taking first potential energy. You can calculate potential energy B. So here how to calculate the potential energy? Their potential energy is equal to mgh mg into height of the object. Height of the object. Here this is a height. Actually their x distance, s is equal to x distance will travel. What is the remaining height? H minus x. Here the total height h. Here how much distance will be traveled? S is equal to x. What is the height at the point B? H minus x. So their height is equal to, in this one, mg into h minus x. So that is, what is the equation here? Mg capital H minus mg small x. So this is the potential energy at point B. And what is the kinetic energy? So the kinetic energy B, so we know the general equation of mv square. So but what is the velocity of the B at the B position? I want to velocity here. I want to velocity at this point. So how to calculate the velocity at the point B? So this is the here A position. This is a position. This is a B position. So the object is a freely falling like this. Okay, so in this case how to calculate there? So this is a u, initial velocity u is equal to 0. So the final velocity vb is equal to, I am taking the vb. Okay, so here some acceleration is a downward, a is equal to g. And how much distance will be traveled? S is equal to x. I want to v, velocity. First you can calculate the v. So for this purpose I am using one formula, v square minus u square is equal to 2as. So v square means vb square, u square initial velocity 0. 2. What is the a? A is equal to g. S is equal to x. So vb square is equal to 2gx. What is the formula? So what is the velocity at point to B? This is the velocity. Okay, so at the particular the distance will be traveled in the downward, s is equal to x. At this point B, what is the velocity? V square B is equal to 2gx. So we know that kinetic energy formula, their kinetic energy at the B position, already we know that of m vb square. What is the vb? This is the value of the vb. So that is 2gx. So 2 cancel. Their kinetic energy is equal to mgx. So here at the point B, I want to total energy. The total energy is equal to kinetic energy plus potential energy. So this is total energy is equal to, what is the kinetic energy formula? mgx. And potential energy, here we know that very well. So this is a potential energy, mgh minus mgx. Here mg capital H minus mgx, just substitutions. So where plus mgx minus mgx will be cancelled. So E is equal to mgh. So at the point to B position, at the point to B position, so what is the total energy? mgx. So please remember at the point to A, so this is the A position. What is the total energy? mgh. At the point to B, what is the total energy? mgh. Third one, at point C. At point C means this is the initial point. Okay, this is the initial point. What is the position? A position here. This is a ground. So when this ball or object is reaching another point, this is a B position. And it is reaching the another point on a ground, I am taking the C position. So one is point A position, case 1, point B second case, point C, third case. So I am taking the point C. At the point C, here this object on a ground, their object on a ground I am taking. So what is the kinetic energy at C and what is the potential energy at C? This is my concentration. So because the total energy at point C is equal to kinetic energy plus potential energy. For this purpose, first you can taking potential energy formula mg into height. mgh general formula mg into what is the height at the point C on a ground? There is no height, so therefore mg into 0, their potential energy at C is equal to 0. But what is the kinetic energy? Their kinetic energy is equal to half mv square, half mv square. The ball is reaching at this one, so I am taking the velocity vc. So their ball is freely falling, the same case. So by using v square minus u square, v square minus u square is going to previous case same 2as. Okay, so v means here vc square. What is the initial velocity? U 2. What is the a? A is equal to small g. S is equal to how much distance will be traveled? Capital H. The ball is reaching at A to C. How much distance will be traveled? A to C, H distance will be traveled. So I am taking here vc square minus 0 is equal to 2gh. So therefore vc square is equal to 2gh. So what is the kinetic energy formula? The kinetic energy is equal to half mvc square, that is 2gh. 2 cancel, so their kinetic energy is equal to mgh. This is the kinetic energy. What is the total energy? E is equal to kinetic energy plus potential energy. So that is E is equal to, what is the kinetic energy? mgh plus what is the potential energy? 0. So E is equal to, what is the equation? mgh. What is your observation at the A point, B point, C point here? So this is the A point, this is a B point, this is a C point. Okay, so it is a freely falling object. Okay, so A point, B point, C point, their object is a freely falling. What is the total energy in the previous case? E is equal to mgh. And at the B point, what is the total energy? E is equal to mgh. At the C point, what is the total energy? M. So what is your observation in the freely falling body? The total energy at this any points A, B, C is equal. So this is called conservation of the energy. The conservation of the energy means always the internal forces is conserved. There is no external forces is acting, no external forces is doing. So this is called one of the case, that is the conservation of. Another one, the total mechanical energy is constant, their energy will be changes one form to other form. So that means what happens, sir, at the A position it is only potential energy, their kinetic energy is equal to 0, we know that. Here at the C, their potential energy is equal to 0, only kinetic energy. So what is your observation when the object is freely falling? So that is A to C, their potential energy here 100%. And at this point, their potential energy 90%, 10% kinetic energy. And middle, their potential energy, for example 50% potential energy, 50% kinetic energy. And at this point, their 30% potential energy and 70% kinetic energy. In the finally at point C, their 100% kinetic energy. What is your observation in this case? When a freely falling body, their potential energy is converted to kinetic energy, but the total energy will be constant. So the always, what is the conservation of the energy? The energy is changes one form to other form, but in the total remain, the total mechanical energy will be constant. So this is called conservation of energy is a freely falling body. Thank you very much. The next one, the energy. So what is the definition of the energy? Energy of a body, definition. Energy of a body, energy of a body is its capacity to do work. So what is the energy? The energy of a body is its